Energy efficiency is a core challenge in 5G RF design. As networks scale with massive MIMO, wider bandwidths, and dense deployments, power consumption directly impacts cost, sustainability, and performance. In this episode, we'll look at how energy efficiency is addressed, from UE hardware all the way to network-level RF design. 5G delivers massive capacity and ultra-low latency, but it also increases energy consumption. To keep networks sustainable and cost-effective, energy efficiency has become a key RF design goal. From device hardware all the way to network operation. In both UEs and base stations, the power amplifier is the biggest energy consumer. Additional losses come from multiple RF chains, signal processing, and continuous control signaling. 5G increases bandwidth, antenna count, and operating frequencies, all of which push RF hardware harder. Without optimization, performance gains would come at an unsustainable energy cost. At the UE side, energy efficiency starts with high-efficiency power amplifiers and then techniques like envelope tracking. 5G also introduces advanced sleep and idle modes to minimize battery drain when data is not active. Features like discontinuous reception, smarter measurements, and reduced always-on signaling allow the UE to sleep longer, extending battery life without sacrificing performance. At the base station, energy efficiency focuses on high-efficiency power amplifiers, shutting down unused RF chains, and adapting power consumption based on real traffic load. Massive MIMO improves energy efficiency by focusing energy only where it's needed. Instead of broadcasting power in all directions, beamforming concentrates RF energy toward active users. Efficient scheduling and power control reduce unnecessary transmissions. By avoiding retransmissions and excessive margins, the RF layer directly contributes to lower energy consumption. At the network level, operators can dynamically switch off carriers or even entire cells during low traffic periods, dramatically reducing energy usage without impacting user experience. Energy efficiency is now measured as bits per joule, balancing throughput against power consumption. It must be considered both during RF design and during real-time network operation. RF engineers constantly balance trade-offs: coverage, capacity, cost, and sustainability. Energy-efficient RF design ensures 5G remains scalable for the long term. Energy efficiency is a fundamental design goal in 5G systems. In practice, power amplifiers and RF chains dominate overall power consumption. That's why optimization must be considered end-to-end, from the UE RF front end through the G-Node B and across the network. In the final episode, we'll summarize the key RF lessons from LTE to 5G and share practical insights from real-world deployments. That's all for today. If you like this video, please subscribe, like, and share. Thank you.